let's give those derivative rules a little bit of use, shall we? We want to find the derivatives of each of these. They're all natural log things. Let's come over here so I have some more room to write. All right, so I'll start with number 1 because that's what I do. I want to find the derivative of the natural log of 3x. It's a composite function since 3x is stuck inside of the natural log, so I'll have to use the chain rule on it. Y prime is equal to 1 over 3x, so there's the derivative of the natural log of 3x, times the derivative with respect to x of the interior function, which is 3x. The derivative of 3x, of course, is just 3. So I've got 1 over 3x, and then multiply it times 3. And what happens with your 3's? Cancellation crayon. It's been a while since I've actually had to take it out. Whew, but it felt good. And I get 1 over x. All right, that's kind of strange here. The derivative of the natural log of 3x is the same thing as the derivative of natural log of x all by itself. Well, here's the reason. I can use a property of I can use a property of logarithms to expand that out. That's the product property. So the y is equal to the natural log of 3x is the same thing as the natural log of 3 plus the natural log of x, right? And now when I take the derivative, this guy is a constant, so its derivative is just 0, plus, and the derivative of the natural log of x is just 1 over x. See there? Interesting, right? I'm glad you think so. All right, let's look at number 2. Y is equal to the natural log of x cubed plus 1. Again, a composite function. So y prime is equal to 1 over x cubed plus 1. That part of the natural log derivative is so easy. It's 1 over whatever the interior part is, but then don't forget to multiply it times the derivative of the interior function, derivative of x cubed plus 1. All right, and the derivative of x cubed plus 1 is just 3x squared. So this should be equal to a 3x squared over x squared plus 1. Now I'm really doing some extra stuff here that I don't think is necessary, especially when you get some experience doing some of these things. We talked about how the derivative here is just u prime over u, so why don't I just do that? Why don't I just look at this as, maybe I do this in purple, if y is equal to the natural log of x cubed plus 1, why don't I just say the derivative is equal to, hey, what's the derivative of the interior? It's 3x squared over the interior. And just do it in one step. That's what I would encourage you to do. Save yourself some time. All right, number 3, if I'm not mistaken, is a product. X times the natural log of x, which means that we will have to use product rule. X times the natural log of x, y prime is equal to, the derivative of the first one is 1 times the second one, the natural log of x, plus x times the derivative of the natural log of x, which is 1 over x. Hey, it's time for the cancellation crayon again and cancel out these x's to just get 1 left over. All right, this is kind of confusing notation, natural log of x plus 1. Where's this 1? Is it inside the natural log? I guess you could put parentheses around this, or you could just throw that 1 up front and avoid some parentheses and also avoid some confusion. There we go, that looks good. And we have one more. And we have one more. There we go. Number 4. What is it? All right, we have another composite function. This time, natural log of x is stuck inside of a cubic function. Y is equal to the natural log of x, quantity cubed. So we'll have to use the general power rule on this, which says that we leapfrog this power down, subtract 1 from that exponent, y prime is equal to 3 times the natural log of x, quantity squared, and now multiply it times the derivative with respect to x of the natural log of x. The derivative of the natural log of x, it's almost as easy as the derivative of e to the x. It's 1 over x. Why was I about to pull out a different color of crayon? I don't know. So I've got 3 natural log of x quantity squared times 1 over x. Make that look prettier. Okay. And then, of course, I can just put this x down here in the bottom of this thing. Make it look even nicer. So 3 natural log of x quantity squared, all of this over x.